Good evening, friends. Welcome to the domain analytics program. So we were saying legal and law analytics, and today is the last day. We will be seeing neural networks. So we'll be learning a bit about deep learning, neural networks. Let's see. So today's agenda, we will be learning about neural networks, how it works, perceptron, what is multi-layered perceptron, what is an activation function, what are the error surface, what is gradient descent algorithm. Along with this, a use case. So what are the applications of neural networks in legal analytics? So neural networks can be used within inference engines. Okay. So it can be used as legal expert systems. It can be used to reason with cases. Now let us, the next application is use of neural network in legal information retrieval system. Also it is used in legal expert system. So how does a neuron work? So what is a neuron? Okay. So neuron is a part of our body, human body or human brain to be specific. Okay. So it has dendrites or this hair-like structure, you can see dendrites. It senses or it, you can say, takes impulses from outside. Okay, it takes impulses and sends it through this axon to the terminals to the next neuron, and by this it is transmitted to the brain. Okay, so if we see, these are for the input signal. Signal is processed using this nucleus, this you can say neuron nucleus, and signal is transmitted using this axon. Okay. Now, our neural network systems in data science also tries to replicate this. It tries to mimic this. Okay. So if we talk more about this, we can see dendrites are there, which receives signals. Okay. There will be a delay synapse. After this, it will go to the cell body and this nucleus, and it will be processed and an output signal will be sent to the brain. So likewise, we can see here also we are having our neural networks. So we are having some input nodes. These are all inputs. X1, X2, X3 are input nodes. Then we are having some hidden layers which process this information and send it to the output layer. Now, what is a neural network? In data science, let's see. So it is a machine learning model which is inspired by the network of biological neurons in our brains. Okay, based on the neuron structure of our brains, it is developed. Neural model of our brain. Now, neural networks are of, you can say, three types: ANN, CNN, and RNN. This ANN or artificial neural network, or it is also a multi-layer perceptron. So perceptron will be learning just in a few slides. Then we have convolution neural network. This can be used for images, videos. Okay, RNN can be used for multiple cases, for Time series model also, we use RNN. Okay. Now this human brain, it is made up of about 85 billion neurons. Okay. So we are having a huge, network capability. So we can process a tremendous amount of knowledge altogether. For instance, a cat has just about a billion neurons. Mouse has about 75 million neurons. Cockroach has about a million neurons. Okay. So in contrast to that, ANN contains very few neurons. So it can be counted over several hundred only. Okay. So it is not likely that we'll be creating a brain capable of, outthinking us. A brain, or you can say an artificial neural network, or a neural network which can, take over the humankind. So it is now not a possibility. So there is no need to be afraid. Now, what is a perceptron? So we talked about multi-layer perceptron, MLP. So what is this perceptron? What this is? So perceptron is a two-class or binary classification machine learning algorithm. So if we talk about the building blocks of neural network in our brain, they are neurons. Okay. And they measure weights and activation functions. Based on these three, they can transfer the feelings, you can say, senses, impulses. Now it has a single node or neuron that takes row of data as input and predicts a class label. So neurons have weighted inputs, threshold values, activation function, and an output. So basically, input followed by some threshold value, followed by an activation function, then an output. Okay, this is the, you can say, diagram of a neuron, working of a neuron. The same thing can be achieved by calculating weights of inputs and a bias. Bias we can set to 1. The weighted sum of the input of the model is known as activation. Okay. So activation, what is activation? It is weighted sum of inputs plus bias. So basically, if we draw this computerized neuron, we will be having inputs. Okay. And they will be having some weights W. Suppose this is X. And here we will be having an activation function. This will take weighted inputs and bias and give us output. Okay. So we can say WX into WX, so WX plus WX plus WX plus WX, weighted sum of the inputs we are taking and adding the bias to it to get the activation. Similar to, we can say, real neural networks. So here, if we see the activation is above 0, the model will have an output 1. Okay, it will only have two outputs, 0 or 1. So if activation function, this value is greater than 0, okay, it will have a value 1. Model will have the value 1, and if it is 0, it will be 0. Now all the inputs are multiplied by model coefficients. You can see this model coefficient weights, we can say. So as in case of linear regression or logistic regression, normalization or standardization of the data prior to using the model will be most successful approach. Okay, like this, we will be adding weights to the inputs to find this activation. So randomly initialize, we are initializing this weight vector W0. Okay, and it will be repeated until we get the error less than a threshold value gamma. Okay, or max iteration we are placing. So this will decide what will be the max iteration. And for each training example, we'll have something like this: weight of the next layer will have weight of the previous layer Wn plus some learning rate into error into the input weights. Okay. This is also same thing. We are just calculating it, different layers. So if we see, this is the structure. We are having inputs here, x1, x2, up to xm we are having. These are all input vectors. Okay. And these are having weights w1, w2 up to wm. We are adding all the weighted weighted inputs w1 x1 plus w2 x2 plus wm xm. Okay, here we are getting that summation integration function aggregating input signals. Okay, once that is done, we will be applying an activation function. Okay, so that we'll apply this input to an activation function to convert its shape, basically, if you can see. And after this activation, we will get the output. So we'll see activation function what we can use. Now this is just a single perceptron. This is just a single perceptron, but we can also have multiple layers lying in between inputs and output. So let's see. If we are having multiple layers, that is known as multi-layer perceptron. Okay, so multi-layer perceptron is a supplement of the feed-forward neural network. It consists of 3 layers, basically. So one is input layer. You can see here, this is the input layer. Then we'll be having hidden layers. Okay, they can be more than one hidden layers, and an output layer. Okay, so whatever weights input will have, okay, they will have different weights going to different hidden layer nodes, and accordingly the weights are calculated, or the input weighted inputs are calculated. Okay, so the input layer receives the input signal to be processed. Okay, the input layer is given the input signal that is required to be processed, and this task is similar to prediction or classification, and it is performed here on the output layer. Now, number of hidden layers that are placed in between the input and output, okay, they decide the computational power. If more number of layers are placed, we can design a more complex neural network. Okay, it can be modeled for complex models. Now what is activation function? So activation function, it decides whether a neuron should be activated or not. So activation function decides whether a neuron should be activated or not by calculating the weighted sum of the and then adding the bias to it. The purpose of the activation function is to introduce non-linearity to the output. Okay, so we are having many activation functions. Okay, we are having step function, ramp function, sigmoid, tan h, relu, elu. Okay, max out, leaky relu. So you can see elu. It gives x when the value of x is greater than or equal to 0 and a value alpha into e to the power x minus 1 when x is less than 0. So we can see the graph will be like this. Okay. Now leaky relu. So it is same as relu, but it for relu, if we are having a negative term, it will be 0, and for positive, it will give us values. Okay, but leaky relu, it gives a value for the negative terms also. So it will give a value x if x is less than 0, or it will give a value 0.01x. Okay, but relu will give a value 0 if it is less than 0, x is less than 0, and a value x if it is greater than 0. So these are some examples of the activation function we are having. Now what is a error surface? So we can say error surface is the central theme in the neural network research, and it is used to find the right network for a problem. Now let's talk about the gradient descent algorithm. Okay, so it is an iterative first order optimization algorithm by which we can find the local maxima or local minima. Okay, now this method is commonly used in machine learning and deep learning to minimize a function, a cost function or a loss function. Okay, so here if we take an example, how does it work? So suppose we start here. This is our function, okay, and this point is the minimum. So we continuously keep moving, okay. So when the slope of the function changes sign, okay, if the slope of the function changes sign, okay, at the position where it changes sign, we'll say that is the minima value, minimum. Okay, and the sign change will be at the minimum point. So this minimum can be local, can be global. Okay, so if we can change the starting position, if we can change, we will be able to know whether this is a local minima or not. Okay, so suppose if we are having a graph like this, or the function curve like this. So if we start out here, we will find this as the minimum value. But if we start here, so changing the starting position, we can reach the global minimum. global minimum value we can reach. Okay, if we start here, this is the minimum point we'll reach. If we start here, we might be able to reach here. Okay, but this reaching here depends on the learning rate. If the learning rate is set too high learning rate if you set, then it might never converge in the minima. It might jump from here to here, here to here, here to here, here to here, and it might never converge. Okay. So we should not set our learning rate too high or even too low. So if we set our learning rate too high, we will get a case, an error case, which is known as exploding gradients, where this explodes and reaches, we can say it covers a large distance basically. So it will never converge. Rarely it will converge. Now, if we set an learning rate too low, it will converge, but it will take a very long time to converge. Okay, it will be means if we take the learning rate too low, it will seem to be not moving. Okay, and it will take a very long time to reach. This condition is known as vanishing gradients. Vanishing gradients and exploding gradients. Now some points which we need to remember. Okay, neural networks are a part of deep learning and they ultimately come under artificial intelligence. Now this artificial neural network neural network, it is a computational model that consists of several processing elements and receive inputs and deliver outputs based on the predefined activation function. So whatever activation function we have given, based on that, it will deliver outputs from the inputs. Okay, next, convolution neural network, CNN models. So a CNN model or a convolution neural network model is an artificial neural network model that is used for image processing or image recognition. Okay, and it is specially designed to process pixel data. Recurrent neural network. So recurrent neural networks are a type of neural network where we can say the output from the previous step is fed as input to the current step. Due to this reason, they are used in many techniques. Okay, so they can be used for sequence classification, sentiment classification, video classification, sequence labeling. Okay, part of speech tagging, named entity recognition. Also, they can be used in time series, LSTM model. Okay, there are multiple uses of RNN. So artificial neural network, they consist of input layer, hidden layer, and output layer. So input layer contains some input values, and we give this input value as a weighted sum of all the inputs and weights. Okay, weighted summation of all inputs, and this weighted summation of all inputs is added with a bias term and sent to the activation function. This activation function activates our inputs and converts them into outputs and sends them ahead. Okay, so input layers, we can say it accepts inputs in several different formats. Hidden layers, it performs all calculation to find hidden features and patterns in our data. Output layer, the input goes through a series of transformation using hidden layer, which finally results in output that is conveyed in the output layer. Now, the association between neurons outputs and neuron inputs can be viewed as a directed edges with weights. Okay, you can say these are like this, directed edges with weights. So these are having weights. Okay, and each input is multiplied by this weight. So whatever input we are having, this will be multiplied by this weights, and weighted sum of inputs will be taken here along with bias term if there is any. Okay, so we can say each input will be this input data will be multiplied with the, so let's say X is the input data, X will be multiplied with its weight W, and it will be added with the bias term. And then it will be passed on to the activation function for processing, and it will give us the output. Okay. Now weights normally represent the strength of interconnection between neurons inside a ANN, artificial neural network. Now let us look at one of the use case of neural networks. So neural networks are used for retrieval efficiency. So we know neural networks. Before this, let me tell you some other use cases where neural networks are used. Okay. So neural networks can be used for in legal analysis we are talking about. Okay, so in legal analysis we can use neural networks for document review. Okay, so if we talk about document review, it is the process that involves the task of looking for relevant documents. Okay, looking for relevant documents. Okay, if we take an example, it might be a document containing a specific keyword. Okay, this is one of the example. We can also use this for analyzing contracts. Can be used for analyzing contracts. So clients might need to analyze contracts in bulk or even individually. Okay. So this can be done with a simple ANN model. We can also require the assistance of neural networks for legal research. We might need use of neural network in legal research. So basically, legal research, we can say it is finding of relevant cases, finding of relevant cases from historical case data. Okay, it is a very laborious process if you are not using, data science to look for it. But with AI, we can do it easily. Okay. Also, predicting results. We can use neural networks or AI technology to predict results. Okay. So if we want to know what is the probability of a win or a loss, okay, or how much it will cost, or how to settle this case, whether to fight or take a plea, okay. So these can be, so we can use ML models, AI models, okay, to access relevant data based similar to this case, relevant data, and using this data, we might be able to predict the probability of the outcome of this proceeding. And using this outcome probability, we might decide what to do in the future. Okay, now coming to this example. Okay, so here we are trying to retrieve case documents. Retrieval system, it is basically a retrieval system. Document retrieval system. Now this retrieval system is required to understand non-standard text. But now we do not have that much technology. Okay, so we go for special text recognition scheme of small scale. Recognition skill of small scale neural network system. Network system. So it provides this small scale neural network system. It provides a feature field extraction of semi-standardized text file. Okay, so our text files are not standardized. For that, we are using us. So we will not be able to retrieve this using the preferred system, which is we are using a robot algorithm. We will not be able to extract using this robot algorithm. So we need to come up with a new plan. So we go for small scale neural network, which provides a feature field extraction for semi-structured data. Okay. Now, basically what happens, the overall schema of this file will be same. Overall schema of legal documents will be same. So we can use this to extract the data. Format will be same. Okay. So we will use this property. As the schema is same, so we can extract the data through using this schema. Okay. So if we look at the scheme, how we are, using machine learning to find the documents. So suppose we are having a case file. Okay. Now this case file has some schema like name, legal person name, legal person name, claim extraction, defense opinion, like this we are having. And result. Okay, so a document contains these all pointers, and under this some paragraphs are there or some text files are there, texts are there. So we will use some of the methods like identity extraction. Identity extraction, here we can use corporate identity, and from result we can get citation result. What was the enforcement, and what was the appeal or protest? What was the appeal? Okay. And from this We might also be able to find the field meaning, FI, field meaning, the field sequence number, the start character pointer and the end character pointer. Start and end character pointer. Okay, from this we can also get data like reference number. What is the reference number of this? What is the file number? And what was the judgment time? Okay, so this we can extract using this. So for retrieval efficiency of civil litigation case, this research introduces a fuzzy neural network. Okay, this use case which you are talking about, it uses fuzzy neural network algorithm and it constructs a targeted retrieval algorithm system. Okay. So you can see we are having this case file. So first we will do string sequencing, and from this we will use this fuzzy neural network algorithm to find out field meaning, field sequence number, what is the start character pointer and termination character pointer. So this we can, using these we can then retrieve the documents, the required documents. Okay, so this was a use case for our neural network retrieval efficiency. Now let us go to the codes. Let me open the codes. Okay, so this is again a classification problem. So here we'll be using multi-layer perceptron. Multi-layer perceptron to find the effect of this, or we can say crime rate in Chicago. Okay, so I am importing the libraries Matplotlib, Seaborn, Pandas, sklearn, train test split, precision score, recall, confusion matrix, classification, so evaluation matrix basically. So we'll be using this. So I'm just loading all the files here. Okay, so this is a snippet of the file. We can see we are having unnamed 0, ID, case number, date, block, IUCR, primary type. The primary type gives us the case type, description, total description of the case, location description, where it happened, arrested or not. Okay, like this we are having many columns. These are all the location. Okay, I just ran the info and I got the information on all the columns. So basically many object columns we are having, but most of the columns are float or integer numerical. So we are just dropping the null values which we are having. Okay, and we are taking a sample from this whole data. Okay, the sample is chosen and I am dropping all the irrelevant columns like unnamed 0, ID, case number. After dropping, I am also converting this date time into individual columns. day, month, year, hour, time, second. Okay, and then I'm converting all the categorical attributes to numerical. So for this, I'll be using factorize method from pandas. Okay, once this is done, I am taking this target as the primary type. Okay, means our output column will be primary type and rest will be input. Okay, so if we draw the graph for this bar plot for this output column, we are getting theft is the largest amount of crime that has been committed, followed by battery, then criminal damage, narcotics. Okay, like this we are having. So what we will do, we see that the data is imbalanced here. So you can see theft we are having so much value, but other things where we are having very less value. So what we are going to do, the less occurring crime type will be just combining it into a common others crime type. Okay, so we are for that we are taking from this graph, we are taking the tail last 13 you can say least frequent crimes we are taking in our others column. Okay, and I'm grouping them and keeping them here. Okay, so now we can see it is a bit so we are getting some values now correctly. Okay, so after this is done, I am just factorizing it so that it will be numerical, so that we can work on it. Okay, now I'm just splitting them into X and Y, or target and predictors, and I am doing also drawing the heat map here. You can see. So heat map shows how much dependency is of one data with other data. Okay, so if I am getting a color of dark red, you can see like this, then we will see it is fully dependent like this here. You can see here. So this X coordinate and longitude are fully dependent, obviously, because they are same thing. Okay, and white are negatively correlated. Okay, so if we see this correlation, so a correlation coefficient will be ranging in between values of -1 to 1. Well, value closer to 0, it means no correlation. A value closer to 1 means strong positive correlation, and a value closer to -1 meaning strong negative correlation. Okay, so we are just finding the correlation with the primary type. Okay, so with primary type we find that FBI code has strong correlation. So whichever three most correlated columns will be taking, so it is FBI code, IUCR, and description. Okay, domestic we are not taking because this has the lowest correlation coefficient with our output data. So we'll be using these three. So we are using feature selection method for this. Okay, using these three, we'll be training our data. These three will be our input and others will be output. Okay, and I'm using that input and output, and I'm splitting my data into train and test. Test size is 20%, train size is 80%. Okay, so we can see 80,000 training set we are having and 80,000 rows in training set we are having, and test size is we are having 20,000 rows. Okay, then we are using the MLP classifier. Okay, MLP classifier model we are using here, and the solver here we are using is Adam. Alpha value we are taking E minus 1. Hidden layers, total number of hidden layers we are taking is 40, and random state we are taking 1, and the max iteration value 1000 we are taking. Okay, this is the initialization of the model. Once this is done, we are also fitting this model on our train X and train Y. Okay, once we are finding this, once the training is done, we are also predicting it on the features or the Y, on the test features, you can see. So from that, now we are evaluating the model. So model evaluation, we are checking for accuracy, recall, precision, F1 score, and also we are drawing the confusion matrix. So you can see accuracy of 97% we are getting. So we are getting a good accuracy, 97% accuracy. Also recall is 97%. Precision is also 97%. F1 score is also we are having 97%. So overall 97% accuracy we are having. Now it is not that just we will find the test accuracy and that will be it. So we will also have to check for overfitting. So this is the test accuracy. We also have to test for if it is overfitting, underfitting, what is the issue. So that for that we'll be again checking on the train data. Okay, so again I'm checking the same thing on train data. So let us do this. Okay, on train data also we are getting closer to this. Okay, train data also we are getting closer to this. 97 point something. So it is a right fit model. Now we are just checking the classification report. So if we just check this classification report, okay, so we can see a precision score of 1, or the lowest precision score is 80%, sorry, 78%. So it is a, you can say, good model. Recall also you can see, so here also in offense involving children, this is the one where we are not getting that much good result, but for all other crimes we are getting good result. So we can say overall we are getting good result. Okay, so accuracy of 0.97 we are getting. So we can also see this MLP classification report. Okay, precision, recall, and F1 ratio. So apart from this, offense involving children and others, we are getting overall good result. So we can say this, our MLP Perceptron will be able to predict with good accuracy. Okay, given the input, we can easily predict the crime. What crime can be committed, or what crime might be, being committed at that place. Okay, friends, so that was all for domain analytics program. So we'll try and prepare this domain analytics program. And friends, there is also a Python session starting on 11th July. Okay, this will be from 6:30 p.m. to 7:30 p.m. Do attend, do register for this Python session, and it will be conducted by Bernisa. If you want to get more clarity on Python, I would recommend you to attend this session. So yeah, thank you everyone. Have a good day. We'll end our session here.